So guys, the quick demo of what my system is capable of. So we press I key, we can see two slots. Items here can go both to different slots. Let's say this one is the pouch, this one tall is the bottle of whiskey, this on the right is the backpack, those small two are donuts. By default, those pouches can go to both back and hand slot. The order is made inside the array of the equipment slot enumeration. So the first index declares the first entrance. We pick up to the back, we pick up to the hand. Now our slots are occupied and we cannot store our backpack like this. Backpack can only go to my bag, so once I drop my pouch, I can pick it up. You may see that I have 4x4 dimensions and 1x2 for our pouch. The pouch itself consumes 2x3 dimension slot. Once my hand is empty, I can pick up a bottle like this. Next one, we try to pick up another bottle and it will be added. Also, depending on the order of those backpacks. As the backpack here is the main one, it will try to find the place here and here. For this item and for this item. Let's say we're gonna drop one element and rearrange the order. Now if I try to pick up, let's make it like this, the bottle, it won't be suited here and here, so it will go to this slot, like this, the best top left corner. You may also see they have donuts, but we have free space here and here, so donuts will go there, like this, and like this. We can drop it, pick it up once again, and you may see that everything is on their place. So what we have? We have 3 bottles here, and we have 3 slots. By this I mean that once we pick up this one and this one, but we have the free slot up here in this, what is this? It's a pouch. So if we have no free space here, this bottle will go to this pouch, like this. But once again, if we have something here and we have free slot up here, it will go at the empty slot. So yeah, multiple nested bags. Hello guys. So I have some great news, but fortunately at this particular moment I cannot talk about them too much. But due to those changes, I've decided to make the limited time offer for my inventory and equipment system. So this month, this feature will be completely free, and you may download the sample file on my public Patreon page. In this particular video, I'm going to explain how the system works, and it's also how to use the tutorial. This feature relies heavily on my point-and-click interaction system that I also made, and you may find this tutorial on my YouTube channel. For all of you, my subscribers, I'm gonna make the in-depth step-by-step tutorial how to make this system from the scratch, and I guess I'll upload it probably couple next weeks. Obviously this system is way too complex and it's gonna be a tough challenge for all of us. I guess we would start with making the whole essential data stuff, such as blueprint actors, data structures, data tables, UI widgets, and so on. Then we're gonna fill the variables, make the functions with their inputs and outputs. Next, we're gonna recreate the flow, and that's gonna be it. I also would like to thank Zector Lab. It's the guys from London. It's not a paid promotion, honestly. They were just too generous to allow me use their model for my presentation here. This cruel doll is actually astonishing good. Yeah. Well, let's get started. I probably make this one in one try, and I guess you won't be, no, like, it's not the perfect edit, because it's 22 p.m. right now, and I'm too tired, but I need to make this video. So, the whole system here is based, as I said, on the interaction. We have the interactable base class. It's the parent class of all items that I have in my game. And as you can see, it contains nearly of nothing. When item is initialized on the scene, just try to get the first entity from the array of primitive components with the specific tag. The primitive component stands both for skeletal and static meshes. I use this one as the interaction trigger, so I change the response to my custom trace channel. Once item is on the level and I'm hovering my mouse over it, I should trace against one specific channel, not against all items. If you don't have this one, oh, I also have a bug with my mouse. The left mouse button sometimes produce double click. So if you don't have this sort of logic, your interaction simply won't work. You may also see that I have those events that are implemented using the interface. The perform action is the major function, which is overridden inside the children that are derived from this base class. Those are consumable base and container base. You may see that I have so-called function called parent function. It means that if I have parent, the first one gonna be this logic executed, and only then next part from the child will be executed. You may also see that I have the placeholder static mesh component, which already has the tag of interaction. It also has the custom collision. So it's the query and physics both. You may see that I have block by default for everything except the pawn. Sometimes pawn can be stuck inside other items, so that's my workaround. Interactable objects collide with each other in the world except of pawn. And that's because it actually suits the game, and I'm withdrawing my items in the area nearby my character, so it's like 100 units in all directions. Let me check whether my capture is working. Yes, it does. Well, you may also see that this perform action event has its own custom logic. which requires the two more entities. The one is equipment component. It's an actor component which is added to my player character here. And what I'm trying to say is that the flow next one. I have the equipment slots like hand, back, belt, and so on. If I have an item on the scene, I try to pick it and equip to my free slot. So that's the call to function inside this equipment component. If I fail, and probably I have already some sort of container, I try to look at the empty space there and store it like this. And this function is implemented inside the item object. It's another entity. It's actually the my cat is sleeping. Okay. It's the main entity for all interaction here. It contains of data and the functions, but it doesn't have any physical representation because it's derived from the simple object class. And here you may see this implementation, pick and store, where I try to find the free place for my item. So if any of those conditions doesn't succeed or don't succeed, I simply leave my item on the scene without any changes. But if I can, I pick it, equip or store, and I destroy my item. Also, the reason why I have this interaction tag, because you may have kind of nested blueprint entity with a lot of meshes, like the fireplace, where you can have this mesh of fireplace, the logs, the branches, right? But you don't need to interact with the whole item. You just need to have one particular item with the proper collision set up. And all other things should not be changed. That's my dishwasher. I don't know whether you hear it or not. Well, the whole interaction, as I said, is done here in the player character. Here I have find interactables. It's the function which is called every 0.1 second. As you may see, I'm trying to trace with my mouse, and execute can stop interaction via my interface. This logic prevents me from calling these events too often. So it's sort of like do once with the reset functionality. As it's the top-down projection and the whole logic is behind the left mouse click, the flow is next. If I press and it's the simple location, I move to it. If it's an actor, depends on the context, I'm gonna try to interact with it, whether it's NPC, if it's enemy, I'm gonna try to hit it, and so on. If one condition fails, another one will be executed. I have the action graph. It's the separate event graph, just to keep my blueprint clean and tidy, where I have this sort of logic. It's another timer event, because once I start interaction with an object, I need to check the distance between me and my item. If the distance condition succeeds, I simply destroy this function. I mean, I destroy or I stop tracking the timer here, and I use perform action message via my interface, which executes those events, this one and this one. Well, what else? Equipment component here also contains of the map, it's the enumeration of the slots and the reference to the item object class. Once I pick up and equip an item, this component knows which slot is occupied by which item. And it also stores the main, let's call it master widget for my equipment. UI stuff here is also some tricky and fancy stuff. The ideology of the interaction system with the inventory and so is that each item can be a container. So you may think of the recursive nested thing, like item, like backpack, can have items inside it with another, let's say, pouch. This pouch can also have items inside it, and so and so. This thing also works with the widgets, and I'm gonna talk about this a little bit later. I'm not gonna cover the whole things here because it's not the in-depth tutorial, just for you to know how you can like work with this, because probably you will start reverse engineer it on your side. It's actually kind of easy. Everything is like can equip to slot logic. So we have the incoming item, where it comes, depending on whether we can equip it to the particular slot. We decide the state of it. So it's all actually pretty simple. So yeah. The item object contains of the data is the data structure of an item, which I'm gonna cover soon. It also have some attributes that are overridden at particular moments of the gameplay, like the current amount or the quantity for our stackable items. As I said, items inside each, the array of other elements that this item can store, and the slot to which this item belongs to. If you talk about how the system is made, and actually inventory, this grid that you saw, it's a simple array which arranged in a proper order. Like from top left we go with the index 0, then 1, then 2. If we are at the end of our row, we start the new column, the new row. So it looks like this. Zero, 1, 2, 3, 4, 5, 6, and so on. And for instance, if we have an item with the dimensions like this, we simply check each cell in order to know whether we can put item here. If we can put it in the top left but cannot here, we simply go to the next index. If this one slot is empty, we're gonna place it like this. So let's talk about data. I have enumeration of the equipment slot, backhand, so it's our like physical representation of like if it's the shirt, I have pocket up here, and no. If we talk about my body, I have space on my chest, on my arms, on my head, my belt, and so on, my waist. And the slot state, which I use in several places. In terms of empty and occupied states, I use them both for like equipment slots, like hand empty or occupied. And in terms of the container, if I have a backpack, it can be empty, it can be occupied by an item, or it can have an item like stackable, so I can have leftover. So I need to check whether how many items I should add to this stack to start the new stack, something like this. I also need to check whether the capture is working. Looks like it works. The data structure looks like this. It contains of several different attributes, such as the reference to the interactable class. And I'm gonna tell you how to use this one. The name, it's the ID. So I use this one to check whether I'm trying to place item over the occupied slot. And if it's, for instance, occupied with the same item, place it next to it, like so-called unique items, which cannot be stackable. I do have two different dimensions, one for the item itself, like short 2 by 3, and the container dimensions, like the pocket here, 1 by 1. As I said, boolean here for item can be not an item but a container also. Max per drop, max per stack. The stackable system is under the construction, but I'm gonna complete it this week. And the equipment slot array. As I said, some items can go to different places. Like I have 2 hands and my bag empty for the pouch. I can place it here, here, and with the maybe on my back. This data table is made using this structure. The reason why I use data tables is simple, because the project is on only blueprints, and that asset requires the C++ project. So I have some elements here, let's say pouch, and the reference to the class. Like I'm gonna show you how to create new items to make them interactable. So simply once you create the child derived from whether it's consumable or container class, the new created item should be referenced here. So let's say we have consumables, donut and whiskey. The same goes for containers, backpack and pouch. This, and this. Then we set our attributes like item dimensions, container dimensions, and the slots where they go. The order here declares how items should be added. So let's say we have 2 empty slots, and if we try to pick up pouch, the first slot it would try to search will be back. Then it's gonna be hand. And vice versa. So if we change the indexes here, it will change the order how the system will try to find the best place. What else? So, about widgets. We have this big widget. We also have something like equipment slot here and the item slot. I'm not going to show you all of them. I just want to show you the idea behind this crazy setup. You may see that it looks like we have like the item slot, container grid, and stack amount. You may also see that setup is kind of crazy. We have the canvas panel here with the reference to the item widget, this one. So that's why it looks like this. But the logic for widgets working is based on the actually widget visibility. So once the whole system is created and all UI is initialized, by default we start with this empty slot. So if this canvas panel with this item is hidden, right? No logic inside this widget won't actually trigger at all. So it doesn't exist, except of memory. Once we pick up an item, this slot will be hidden, like this. And whether it's container or an item, or a stackable item, this widget will appear. Inside the item, as item is a container also, and it's accountable, stackable, we check on different conditions depending on the data that we receive from picking up the item. If it's a container, we're gonna draw this grid, and if it contains item, we also have another canvas panel, this small square, which is gonna be expanded recursively for each item it contains. If it's simple item, we're gonna close this grid. And if it's not stackable, we're also gonna close this thing. And depending whether we have this one visible or not, some logic will fire, some logic won't fire. It's actually kind of crazy setup. All is done dynamically. Even the grid here, let me check, it's under this one, is the shader base grid. All we do is just setting up the columns and rows here as the material attributes of our widget. That's it. Now I'm gonna show how to create the new item, add it so it will work with this inventory system. Let's say we're gonna create an apple. So I go here, I select consumable base, create child class, let's call it BP apple. I'm gonna open up, change the model size. This one, because it's driven from the base class with the tag, already has the interaction tag. And you may see custom collision already. Next, class settings. Here, class defaults, yeah. As you may see, we don't have anything up here. But we need to initialize this item in our data table. So we're gonna get our data table, add a new row, let's call it apple. Now we add here the class of our newly created item, BP apple. Let's call it properly, change its dimension, let's say it will be 2 by 2. And by default, we can leave this equipment slot to be none, so it means that we cannot pick up it with our hand. It should only go to the backpack. But let's say we're gonna pick it to the hand, because obviously it's an apple. Next, we're gonna back to our apple, and here under this data table, we need to select the row from data, so this item knows that this one is an apple with all of this data, because we have the function I don't remember where it is, but nevertheless, this function is called setup data from DB, and it's made inside the parent class. So let's go back to this class, and I'm gonna show it to you. So it just gets the data from the data table, construct the item object, our uObject reference, and all the data, all the functions already is implemented inside this apple. Now we're gonna just bring this apple to the scene and launch the game. Now you will see that if I try to pick it to my hand, it will be added. Just like this. Now if I pick up the container grid, I can place it here, or drop it. Pick up it once again to my hand, then to my backpack. That's how to use this system. So guys, I hope you like this sort of introduction to this nested feature. As always, I heavily rely on you, on your support, so please subscribe, both to my YouTube and, in case you want to support me monetarily, to my Patreon. Leave your feedback and tell the world about me. So, see you soon, guys.